Hearty hello from West Virginia. Or someplace. Anyways, let's get into joke of the day because that we are confident about. So, what is the most educated type of animal? The most educated type of animal? Well, that would be a fish because they stay in schools. Okay, well, speaking of educated, we are going to educate ourselves. We are educated about the product rule, the quotient rule, and the power rule for logarithms. So we're going to use that product rule, that quotient rule, and that power rule for logarithms to simplify and evaluate logarithms. And I've got several examples to make sure we're really good at it. So this is basically just practicing using these power, quotient, and product rules. So in these examples, we're going to expand the logarithmic expression, meaning that we are starting with one single logarithm, expanding it out into several logarithms. So take a look at this first one. We have log base b of x times y to the third. X times y to the third. Now you know that multiplication leads into what? Yes, leads into addition. Just like when you multiply bases for laws of exponents, so you're going to add the exponents. With your logarithms, when you multiply factors, you're going to add the separate logarithms. So this will lead us into log base b of x and a log base b of y to the third. We're going to add those two together. That is your product rule. Now remember, your power rule says if you have an exponent, you can take that exponent and you can slip it down into the front as an not as an exponent, but as a coefficient. So therefore, I'm going to now have log base b of x plus 3 times log base b of y. Now, can I evaluate log base b of x? No, that is because this would indicate b to some outside power. Let's even just put it as a question mark because I don't know what that power is going to be. Is going to equal this number that's on the inside, and that says how many times would I multiply b by itself to create an x? I can't multiply b by itself to create an x. So therefore, I'm not going to be able to evaluate this log base b of x. Could I evaluate log base b of y? Similar idea. That's going to mean base to the outside power, b to some power, is going to equal this number on the inside, which says how many times would I multiply b by itself to create a y? I can't multiply b by itself to create a y. So therefore, I will not be able to evaluate this one either. This is expanded and it cannot be simplified or evaluated. Now, let's take a look at the next one. Once again, one single logarithm, log base 8. So I'm taking 64 and dividing it by square root of x plus 1. If multiplication leads to addition, then division will lead to what? Yes, subtraction. So I'm going to separate this out as log base 8 of 64 minus log base 8 of square root of x plus 1. Notice in each of these cases that base is going to carry over to each of the separate logarithms, and that base of 8 is going to carry over to each of the separate logarithms. Now, this x plus 1, remember a square root is the same thing as a rational exponent. So in other words, that square root is going to be the same thing as an exponent of 1/2. So I'll have log base 8 of x plus 1 to the 1/2 power. Now, this log base 8 of 64, could I evaluate that? Perhaps I can on this one. This is going to indicate 8 to some outside power. 8 to some outside power is going to equal this number on the inside. And what that means to me is 8 to what power? In other words, how many times will I have to multiply 8 by itself to create a 64? Well, 8 times 8 is 64. So my exponent here, that question mark, is going to be a 2. And what that tells me is log base 8 of 64 is just a 2. Now here, can I evaluate log base 8 of x plus 1 to the 1/2 power? No, I can't, because that's going to indicate 8 to some power is going to equal, now that number on the inside is going to be something pretty hefty. It's going to be an x plus 1 to the 1/2 power, and that's going to indicate how many times will I multiply 8 by itself to create that mess? Can't happen. So I cannot evaluate this any further. So the best that I can get out of this is 2 minus log base 8 of x plus 1 to the 1/2 power, but it is expanded and it is evaluated. Now, take a look at this last one. In this one, what's going to happen is, I have one single logarithmic base, log base b, and all this. Now notice I got a lot going on in here. I have multiplication up here because it's cube root of x times y times y to the fourth divided by z to the fifth. A lot happening. So I can expand this one out and I can say, well, this is going to be log base b of cube root of x plus log base b of y to the fourth. But this remember, because multiplication is going to lead to addition, but division is going to lead to subtraction. So now I'll subtract log base b of z to the fifth. Once again, go over that again. Multiplication here is going to lead to addition of these two. Division here is going to lead to subtraction. And notice every one of these carried over that same base. Now, remember, the cube root of x is going to be the same thing as 1/3 power, so it's log base b of x to the 1/3 power. So I'm getting all of these written into into exponents. And now remember that power rule that said all of these exponents could slip out front as coefficients. So this 1/3 can slip out front as a coefficient, log base b of x. This 4 can slip out front as a coefficient, log base b of y. And this 5 can slip out front as a coefficient, log base b of z. Now can I evaluate log base b of x? No, because that's going to indicate b to some outside power, so b to some outside power is going to equal an x. And that indicates how many times would I multiply b by itself to create an x? Well, I can't multiply b by itself to create an x. So I cannot evaluate this one. This one similarly would say b to some outside power would equal now a y. And once again, how many times would I multiply b by itself to create y? I can't multiply b by itself to create y. So I cannot evaluate this. And the same thing's going to happen here because it would be b to some outside power is going to equal that z. And just like before, I can't multiply b by itself to create a z. So that cannot be evaluated. So this is expanded and it cannot be evaluated, so that's the best that that one can get. Now, this is expanding the logarithms using the product rule, the quotient rule, and the power rule. Now let's take a look at the idea of being able to condense logarithms using that product rule, quotient rule, and power rule. So if you take a look at the first one, it is expanded because I've got a logarithm here and a logarithm here, two separate logarithms. I'm trying to put them together as one. I can only do that if they have the same base. Notice it's natural log. What's the understood base? Yes, e. Another natural log, understood base of e. So since they are the same base, I can condense them into one base. However, I have these coefficients that are causing me problems. My power rule says I can take these coefficients and I can slip them up as exponents. So I'm going to do that with each one of those. When I do, I'll have natural log of x squared minus natural log of y to the 1/2. Now remember, 1/2 power is going to be the same thing as square root. So this will be natural log of square root of y. And remember that subtraction leads into division. So division and subtraction go together, multiplication and addition go together. So that means that I'm going to condense it into one single natural log. And remember, the number in front is the one that's going to go on that numerator of your fraction. So x squared will go on the top, square root of y will go on that denominator on the bottom. This is now condensed into one single logarithm. Now let's take a look at the next one. In this one, once again, natural log base e, natural log base e, natural log base e. So yes, I can condense them all into one, all three of them into one even, but coefficients are messing that up. So the first thing that I have to do is slip those coefficients up as exponents because I can only employ the product rule or the quotient rule if I don't have coefficients out front. So when I do that, I'm going to have natural log of x to the 4th plus natural log of y to the 7th minus natural log of z to the 3rd. Now with that, actually let me put that over here so we can see a little bit better. Natural log of x to the 4th plus natural log of y to the 7th minus the natural log of z to the 3rd. That's a little bit cleaner. I like that better. Okay, now remember the addition leads to multiplication. subtraction leads to division. So therefore, I can condense it into one natural log. This addition, I'm going to now multiply these two factors. And this subtraction, I'm now going to divide that factor. So I get natural log of the result of x to the fourth times y to the seventh divided by z to the third. One single logarithm. I've got it. Okay, this one looks very scary, but I think we can get this. I think we can do this. Now, let's work first with everything that's here on the inside before we get to everything else. So working on what's on the inside, I'm going to slip everything up as a coefficient. So this 5 is going to slip up as a coefficient, and slip up as an exponent. My apologies. This coefficient slips up as an exponent. None of these have that. So therefore, I will have natural log of x plus 6 to the fifth power minus natural log of x minus natural log of x squared minus 25. And at this point, remember, what I have here is same base all the way across. So therefore, I can use my product rule and my quotient rule. This leads to division as well this leads to division. So what that's going to indicate is I'm going to have my natural log. My numerator will have x plus 6 to the fifth, but my denominator will have this x as well as this x squared minus 25. Okay, so now I'm going to do the natural log of all of this. Actually, let me do this. Here we go. There we go. But remember, I still have that coefficient of 1/3 out there. But that power rule says that that coefficient that's sitting out here, it can slip up as an exponent for this particular natural log. So therefore, what I'm going to have now is natural log, and this is going to be enormous, but we've got this. Natural log of x plus 6 to the fifth divided by x times x squared minus 25 to the 1/3 power. Now, that does indicate cube root, so I'm going to just condense it a little bit more, and I'm going to go cube root of x plus 6 to the fifth power divided by x times x squared minus 25. There we go. And this is condensed completely. I cannot take the cube root of all that stuff. That's not going to happen. So this is as good as it's going to get. Now, some of you may be asking, why did you not go ahead and slip this one up in the beginning? Because remember, your product rule says you can slip it up here, but within a single logarithm. To slip this up here would be applying it to all of these logarithms, and I don't want to do that. And also think of it kind of like order of operations. Order of operations PEMDAS says do what's inside the parentheses first. So I'm going to take care of all this stuff in the parentheses first, then I'm going to deal with that coefficient that's out front, following proper order of operations. Another thing you may be asking is, well, initially here I had put braces around this, and then I changed it to parentheses. Why did I change it? Because if I was to put braces here, then that would indicate, brackets. I had brackets here, and then I changed it to parentheses. Well, if I put brackets here, then I was going to put braces here, and that would feel a little bit funny to have braces. So I decided to go ahead and put parentheses, even though I've got parentheses here as well. But once I got to this point, and I put the brackets around this, there's no need for braces. So I felt comfortable putting brackets around, braces around this. Brackets around this, because there would be no need for the braces. But that's just a personal choice. So I hope this helps you to understand how to put together your product rule, your quotient rule, and your power rule for logarithms in order to be able to expand your logarithms and in order to be able to condense your logarithms. It's all about simplifying them. And if possible, like you saw here, being able to evaluate them, which you won't always be able to do, but by all means, if you can evaluate it, do it. If you can't, you can't, and you're stuck. So I hope that helps. Have a great day.